We have the fixed wireless internet access that we're going to talk about today. Storm does a lot of fixed wireless, so it's not the same as mobile wireless. It actually is fixed between a building and a tower, and so your building's not supposed to move. So that's what fixed wireless access is about, and we'll be talking about that for the next little bit. So as we start, I want to thank you for being a Storm customer, looking at this webinar, and we're going to look forward to your questions and comments. This is the fourth webinar in our series. We're doing things with Wi-Fi in one of our first webinar. There's also search engine optimization, and we've also got backup and recovery and business continuity that we've talked about to help people figure out resilience. And today it's fixed wireless access. And next up will be notes from the NOC, which is the Network Operations Center. So Storm has been founded in 1996. We provide information for about our internet at storm.ca. 3 offices, high-speed internet. We have our own facilities distribution, facilities-based distribution for fiber in the Clayton area, and also in the 417 Business Park in the VARS area. And we also provide fixed wireless access through a network of more than 250 towers. In addition to connect people up, we also use third-party internet access where we resell DSL, digital subscriber lines, which is basically over phone lines, cable, and fiber. So we resell those from the bigger suppliers that own those facilities, and then you get Storm support with local customer service, so that you're always working with somebody who actually lives in the Ottawa Valley. So we have more than 10,000 customers at this point with both residential and commercial solutions. We have about 50 employees that help all of this stuff happen, and we're proud of them all because they know how to install, and both wireless and wired. Our coverage, most people are quite surprised by the fact that we go from Sharbot Lake on the left or west side, which is north of Kingston, all the way to the Quebec border. And those towers on the far right, the one in silver is actually the tower at North Lancaster. It provides 100 down and 20 up to a group of customers that bought in December, and we've been running that for a while, and now we know we can roll that out across other areas in the network. So we're working on getting all that done, and you'll see the network grow more silver as we move forward. Right now, the little red splotches, they're all 5010s, and we've done a lot of work to upgrade the whole networks, especially since 2020 was a year when the pandemic showed up. Now we're just used to upgrading towers on a regular basis and providing higher speed internet. So we have service to the community. We started with Blues Fest, where we did some special things to help support Blues Fest in terms of the merchandise tents, the beer tents, the gates, the ticket sales, and even sound and lights to stage. So those kinds of things we then had as ways we can support an event, and we've delivered them at Kempville Live and other music fests. We also provide things for Hope Volleyball and county fairs, where generally speaking, it's various food and beverage tents, as well as the ability for people to have Wi-Fi on site. So we've done a lot of that kind of work to help customers out. From a point of view of what happens in the world of municipalities, we've got like downtown Brockville, where we've got the downtown Main Street covered with Wi-Fi, public Wi-Fi, in order to encourage people to stay longer at the restaurants and look things up in the area. We've also got the railway tunnel, which is one of the first railway tunnels in Canada, and it's used as a destination for people looking to walk through a historic tunnel. The light rail transit construction in the Ottawa area, We're probably doing 10 sites right now where we actually connect the trailers in at the site so that they can do time cards, and in addition to time cards, they can do updated drawings. They would have cameras for safety and or theft prevention. And so all of those kinds of things are happening. And when they move the trailer a kilometer down the road, we repoint the antennas to feed them again, so nobody has to wait for wires or fiber to be drawn to that particular trailer. We're also doing things at the Aberdeen Pavilion and other meeting centers. So in the Aberdeen Pavilion, as an example, if you rent the Aberdeen Pavilion for an event, you have an option of getting Wi-Fi with that event, and Storm customizes it with the right name on the Wi-Fi and the right password for you. And we do that for the Army Run and a whole bunch of other things where people rent the pavilion to run an event, and then we provide the Wi-Fi. So we're doing that for people's meeting spaces. We also help in the rural area. The third largest industry in Eastern Ontario is the farm gate proceeds, and so we've been working on smart farms. We're about 150 smart farms in. We know how to connect dairy, crop handling, herds, and even biodigesters. So we're doing a lot of work to help people integrate and make a private network for their farm so that all the stuff can be network enabled. We're also working out in the world of marinas and campgrounds, which of course are often far from a city, and so we help the experience at the campground or the marina become more pleasant for people because they can connect with Wi-Fi. Manufacturing wise, there are quite a few manufacturers that want to work outside the city because they get a lower cost of land. So we've been providing them with wireless access to their buildings, or sometimes fibered access. But we actually do that to help industries in the rural area. Distribution logistics, definitely an industry that is located mostly in the countryside. We are providing some of them with some wireless access for their depots, so that they can do dispatch and things like that. And of course, tourism. And right at the top of tourism, other than the music events, there's also and the county fairs. There's also things like Upper Canada Village, where we do provide the internet, which of course is hidden because in the 1860s you didn't have internet, but we provide internet for safety and an enhanced experience in the area. So those are things that we actually are already doing that can be useful to people. So this is all about internet access and some of the things that Storm is doing with wireless internet access, especially in rural areas, although we do cover the city of Ottawa quite well. So we provide fixed wireless access using our towers. Typically, the fixed wireless access is between two fixed points. So a tower doesn't move, and neither does your premises. So it's not mobile access, which is different because it goes to a cell phone, generally speaking. And so we're actually providing that fixed wireless access between those 2 points. Of course, being wireless, the signal would be impacted by trees, buildings, and the shape of the land. So do you have hills and valleys? So it performs best if you can get a clear line of sight between the tower and the premises that you're trying to hook up. Most of the time, we can provide a signal for up to 12 kilometers if you have line of sight. We have these high-speed terrestrial networks. We actually serve thousands of rural customers using those networks on a variety of frequencies, and the networks are reliable and have low latency, otherwise known as ping time sometimes. So so they'd be way better than a geostationary satellite, and quite a bit better than the typical low Earth orbit satellite. So we do provide those kinds of things. So the two basic kinds of networks that we're talking about are point-to-point. So we are actually providing a signal from your building to our network. And that signal on a point-to-point is dedicated to your business. So if we have 500 megs at the tower available through the antenna, you'll get the 500 megs. And we do provide the internet to the tower either wirelessly or with a fiber, and then your customer premises equipment does connect to our tower. So, and typically those we provide for businesses symmetrical services, and those particular things become signals that are the same up as down. So 100 megabits per second, 250 megabits per second, or even 500. So those are often the typical speeds. We can do a gig and more, but most customers are happy with 500 or less. And then there's point to multipoint. So multipoint means that your premises is one of several coming to the antenna on the tower. So we'll have several customer premises equipment connecting to the storm antenna on a tower, and then the bandwidth that antenna has behind it will be shared between the customers. And many of those connections are 5010 or 120, but some of the new technology is allowing us to push this up so we can actually do 60 gigahertz and produce up to a gig for the customers. We've rolled out some at 250 for customers over the Christmas holidays, and we're looking forward to doing many more of those because it does help that it's not point to point, it's now point to multipoint, and allows us to serve more customers in an area with only one antenna up on our tower, because of course there's limited real estate on a tower. The older connections that we have in our network are 5.1 and 10.1. Storm is upgrading those regularly to try and improve everything that you want, and we're getting that all figured out. So the wireless failover is a concept that's part of what we're doing in 2024 called resilience. So resilience says that you could lose power or you could lose internet. So just as an example, if a fiber meets a backhoe, the backhoe wins. And fixed wireless access could keep your business going, because when the fiber goes down, a failover can be automatic and feed you with a wireless feed, which could be there all the time, a full-time wireless feed anyway. But what happens is it actually does the failover. The backhoe can't get the wireless. So it's guaranteed to be fed from our tower to your building. And we can now push more than a gig. So most businesses can think of this as an insurance policy and can go ahead and use that to put together a plan to be able to do a failover for resilience reasons. If you want to know more about this, you can ask us. It's a concept called mean time to recovery of operations, and basically it looks at how long would it take you to recover from different kinds of issues, and then what can you do to mitigate that risk. And so this is a simple one. The fiber goes out. How do you keep everything going? And the wireless would kick in, and you need some equipment to make that happen, but at least your business is not down. So this would be a typical deployment. This antenna is actually capable of 100 down and 20 up. And what we do when we're doing this kind of deployment is we design things first. So we look at what does it take to get from point A to point B. In our designs, we actually look at the way that things got put together, so between the terrain and the foliage, and that kind of thing is quite important, so that we can have a design with the towers on either end being high enough to go over top of the tallest trees in the neighborhood. We also have ways of designing where we model things before we actually deploy. So we look at what would we get at the 5-click range and the 10-click range off this particular antenna set, given the topology and this particular area, and therefore what kind of speeds could we offer in a particular area. And that includes us being able to run a modeled propagation. So from that modeled propagation, we know that you should be able to get good connectivity, except perhaps in the area where you have the black gap before the green on the far side. That's because there's a little valley there, and that valley doesn't get good signal, or it's predicted that it won't get good signal. And you can take a look at, this is from our North Lancaster tower before we built, and then we were building that one to feed our Baynesville tower. So we looked at how we were going to deploy things. So we have 4 sectors on the North Lancaster tower and 3 on the Baynesville, and then we can combine the propagation expected for Baynesville with the propagation expected for North Lancaster, and understand how the clients in the area could get fed. So that's quite important to helping sales out and understanding where we can actually do things. That was North Lancaster. So North Lancaster is a 200-foot tower. It is a standalone tower. It sits out there, and then if you have line of sight to that tower, you can literally get, on our standard deployment, you can get 100 down and 20 up. And if you were actually to be a customer there, you could get a gig if that's what you needed. Then once we have that kind of thing, we actually know that we can connect. So here we have a lake in the middle. You can see the flat spot in that diagram. So we know what the height is on one side and what the height is on the other side. So we can figure out how tall the 2 towers need to be. We often confirm that by using a drone. So a new position in Storm is that we have drone operators who actually know how to manage a drone to take a look to see that line of sight really does exist between 2 points. And that's been a very useful addition to the way that we do designs and figure things out. Once you have a feed to your building, a wireless feed to your building, you then have to have access points to deliver the signal around the building. We do Wi-Fi design. We go and take a look at what does it take to actually do the connection to people in your building. So part of that is you've got to start thinking about what kind of devices are you going to have in your building that need to connect, and where are they located? So you probably will have more than one access point. You also have to be aware of everybody competes for Wi-Fi. So if you're looking at what's going on in the Wi-Fi world, you have to understand all the smartwatches, all the tablets, all the PCs, and you have to understand how and where they're going to be. And phones, of course, because your phone can also work over Wi-Fi. So all those pieces are going to want part of the signal, and depending on how far a device is from the actual access point, it will actually dictate how much internet might be available to that particular device. So it's important that you understand what that might look like, and what if you're going to have 8 people in the building, all on laptops, all running video conference calls, you might want to do some math to figure out what you actually need for access points to support that. Some of the access points have limited number of, all of them have a limited number of users, just that some of them are in the 256 range and some of them are at 18. So somewhere in between is the truth. So you have to know your access points. You have to know what's going on. So what does an access point actually mean? Well, an access point provides Wi-Fi, but you also need to know that it comes and usually uses 2.4 or 5 as a signal, so that your device is connected that. In the 6E range, it will also add 6G or 6 gigahertz as a new way of connecting. So there's going to be 3 different frequencies that you can operate on. And in addition to the frequencies, inside the frequencies, there are channels. So if everybody buys their their Wi-Fi routers from Best Buy and leave it on default, they might all end up on channel 6 in your neighborhood. So it's important for you to know that you can actually move your device away from a particular channel, and even have your team connect on different frequencies. Plus, you can have a guest network versus the employee network. Sometimes less priority devices can move to the guest network. Some routers are capable of more than one guest network. So all of this becomes important for when you're thinking of the design for how are you going to put Wi-Fi in your building. It's not just as easy as you buy one and stick it up. And right this year, we're totally expecting there'll be a large number of people on Wi-Fi 4 or Wi-Fi 5 that would like to update to a new device so they could get for a better and clearer throughput. Some of the newer devices actually have smarts built into them to move away from congested channels without you having to actually have somebody go in and reconfigure the router to move. They will actually do the calculation, say this channel's too crowded, let's move to another one. So that kind of thing is happening as well. So we can review your wireless availability with you. So we can talk about what's available for your building. And we can also walk the building with you and understand what there might be inside your building that needs to get connected. Do an inventory of what needs to get connected, both devices, and maybe you have IoT. Maybe you're starting to think about smart buildings where you're going to have security access. You're going to have things with the HVAC system, so IoT, Internet of Things, where you have sensors that actually detect, is this floor occupied? I can lower the temperature, lower the lights, all those kinds of things as part of energy savings. It's estimated that you can save 30% by having a smart building, so you can do some math and figure that out. As to whether or not you want to invest in those kinds of things. And if you're actually doing a building, as you'll see down the road, we have new webinars coming up to talk about what you need to do with your building if you're actually renovating or you're building a new one in order to accommodate internet in your building. So how and when to put access points, what kind of media would you use to feed those access points, what kind of bandwidth does that kind of media offer you, and so some of it is Cat 5, Cat 6, Cat 6A wiring. Some of it is fiber, where you have OM3, 4, and 5 with different characteristics to be able to push different signals, different lengths, and different bandwidth through those fibers. So all of those kind of things are part of the taking a look at when you're wiring a building. We'll be having a seminar on that, or a webinar on that, in the next near future. When we do the site survey, we sometimes use drones to check the validity of our line of sight availability. Sometimes you're going to need a tower. We only provide towers because people want them. They're free to get their own tower, but they have to realize that somebody has to climb it to put the antennas on there, and that's kind of an important thing for people to know. So you need to have a certain kind of tower that's climbable if you want to have us put devices on it, or rent a crane and we'll make that part of your installation. And we're going to make the speed of the connection make sense for your business needs. So for many small businesses, they don't need to have a 3 gig connection to the building. So, especially for small businesses that have 1 or 2 employees, and maybe they have a point of sale system and some cameras, but that's about all they need. So those are kinds of things people need to think about. And when you're planning, you want to plan for what does it actually take to support those cameras, and how are you doing that? Are you actually recording on site, or are you actually pushing it to the cloud? There's all kinds of questions that come up with that. So that's all part of what our team does when they come to help you figure out what you need to have. And we'll do some Q&A. We actually have some new antennas that we've put out. They are 60 gigahertz with a 5 gig backup. and we have deployed just before Christmas. We deployed some of it, and we're seeing really good speeds off that equipment. So you can push more than a gig, and we know we tested it at 4.3 kilometers and it was fine. We're now pushing it out to see what we get at 10. And also, because it's 60 gigahertz, you have to worry about rain fade or snow fade, because every raindrop gets in your way for the signal, which is why it has the failover to 5G. Anyway, those are kinds of thoughts on wireless internet, fixed wireless internet access. Do we have any questions? Mr. Arnold, if you unmute yourself, you can ask a question.
Oh, none from me.
Okay, you understood all this already, because at IRAP/NRC, you know all this. Anyway, okay. Well, that was basically the material that we put together to talk about fixed wireless access. We hope it's been useful to you, and we'll be sending a survey out to you shortly to see how we did. Thanks very much, and we'll talk to you again soon. We need your suggestions for webinars. The coming up is going to be the Network Operations Center, to talk a little bit about the team behind the support team and how we manage our network. And we have some slides already to go for that. So we hope you'll manage to make that one too. We'll be sending out invites shortly. All right. Thanks all for coming out.
Thank you.